Well, students, time for a math lesson. And we're going to work with fractions today. But first, I want to start with a little joke. You know what the Empire State Building is, don't you? It's a tall building in New York. It's 102 stories high. It used to be the tallest building in the world. I think it's been surpassed several times. But anyway, it's tall. So, question. Kangaroos, you know what they do. They jump. Can a kangaroo jump higher than the Empire State Building? Well, the answer is yes, because the Empire State Building can't jump at all. Alrighty, enough silliness. A little bit of work with fractions, a little bit of math today. Now, to start with, let's start with the idea that you can rename a 1. There are different ways that you can rename 1, and if we understand that, that will be very helpful when we work some fractional problems. So some ways of renaming 1, you can say 3 minus 2. That's 1. 0 plus 1. And then when you work with fractions, when the numerator and the denominator are the same, that's another way of saying 1. So 2 halves, 5 fifths, 11 elevenths, 100 over 100. Those are all ways of renaming 1 or saying 1. So these are equivalent because they all equal 1. All right, let's look at our fraction problem here, subtraction. 5 minus 3 fifths. Now, anytime you subtract, you may have to borrow, so keep that in mind. And in this case, we will have to borrow because we don't have anything in the fractional column, which is what we do first. We do the fractions first. So nothing minus 3 fifths. Well, I have to get something over here, and I do it by borrowing. So let's borrow from the 5. And anytime we borrow 1. So I'm going to take 1 away. Then I'm going to rename that 1 with this denominator. So the denominator is 5, so to make it 1, you say 5 fifths. And so now our problem reads 5 fifths, we do the fractions first, 5 fifths minus 3 fifths. Well, that's doable. The fractions are the same, they're common. So you just add or subtract, in this case subtract the numerators, so 5 minus 3 is 2. So 2 fifths. But don't forget this, we still have to have it. And 4 minus nothing, and so it subtracts out to 4 and 2 fifths. Now always look, is 2 fifths reducible? And it is not. So the answer, the final answer, 4 and 2 fifths. Now here's another example. 9 and 3/8 minus 2 and 7/8. Now, notice that this is fractional, and so I look at the fractions. Do I have a common denominator? Yes, I do. So I can go ahead and add or subtract, in this case subtract my numerators. But 3 minus 7 is not something that 4th grade students can do. So I'm going to have to borrow. I have to get more over here, so I'm going to have to borrow. And the one that I borrowed, I'm going to rename in 8s. Now, mentally, in my mind, I think 8/8. And then I add that to what I already have here. I have 3/8. I'm going to bring 8 more 8s over. So I'm going to add 3 plus 8. I'm going to get 11/8. Now, it's a subtraction problem. 11/8 minus 7/8, and I can do that. 11 minus 7 is 4. And then 8 minus 2, 6. Now, look at the fraction. Is that reducible? In this case, yes, it is. 4 and 8 are both reducible by the number 4. So, since I'm a 4th grade student, I can do this in my mind. So, the 6 stays the same. 4 reduced by 4 is 1. And 8 reduced by 4 is 2. And so my final answer, and I like to circle the final answer when there's a little bit of work involved. The final answer is 6 and 1/2. If you came up with 6 and 1/4, that's a good step, that's a good start, but you need to finish it off with the final step by reducing. All right, one more. 85 minus 16 and 3/7. Well, this is similar to this, and then I'm going to have to borrow and get some 7s. So let's go to the 5, borrow 1, rename it as 7/7, and then subtract away. Now 7/7 minus 3/7, common denominator, and yes, I can subtract. So 7 minus 3 is 4. The denominator stays the same, 7. And then I subtract the whole numbers. Now I'm going to have to borrow. 14 minus 6 is 8. Alright, 68 and 4/7. Now take a look. Take a good hard look at that fraction. Is that reducible? Is there some number larger than 1 that would divide into both 4 and 7? Up here, no. Over here, yes there was. And over here, no. So this is your final answer, 68 and 4/7. Thank you. Enjoy your math.